Okay, these are the 9394 notes, our first day of discussing vectors in 3D, and actually the first topic is coordinate geometry in 3D, so it's kind of a good basic start to what we're looking at. The first thing we're going to do is just plot a basic point. A 3D plane is kind of funky to look at first, and of course you got to visualize 3D in 2 dimensions as you look at a screen or drawing something flat on a piece of paper. The 3D axis has three axes, x, y, and z. I'll just tell you right now that the x, y, and z, how they're situated on the page can be different from like what I have here to a book to a WebAssign. So I'm going to show you, I have it situated a certain way here so we can visualize a little bit easier for the first time. But when you go to, like, say, WebAssign, if the x, y, and z axes are labeled differently, then you still, we'll do it the same way. You just got to visualize your directions as which directions x, y, and z. But basically, you want to travel parallel to the axis by whatever your coordinates numbers are. So for example, if I'm doing -2, which is a negative x, this is my negative x direction, then I'm going to travel -2. And then what I'm going to do is kind of like a head to tail sort of thing with my directions or my coordinates. So I'm going to pick up where I left off. So when I do the y and go y +4, there's y +4. And then z, kind of weird, z in this case is sort of going down into the ground. So I got to go sort of below that sort of grid you see, and what I'm going to do is, again, in this case above it, but try to visualize. Now this one, because I don't have any tick marks really on here, I'm just kind of estimating what 5 is in comparison to 4 in comparison to 2. So I'm saying that's about 5, right? And then out there sits my point. The other thing we can do in a few minutes when we get into vectors is if we were to go from 0, 0 to that point, that would be a vector in 3 dimensions. So plot a point is, I think, fairly easy. On this grid, I think it works nice. When the grid gets kind of rotated or the axes the labels get changed, you might have to visualize a little bit differently, but essentially you're going to be doing the same thing. Here's one more run at it. And pull the vector out of there for a second. So -4 in the x direction, so I would go -4 in the x direction, -3 in the y, so now I'm going to run along here, -3, and then negative going down below the grid. So again, this one I'm just sort of, estimating what 6 maybe is in comparison to 3. And then if I was talking about a vector, this idea as a vector, from 0, 0 to that spot would be considered to be a vector in 3 dimensions. So applying a single coordinate, I think, fairly easy to do. Just got to be able to visualize that correctly. I know, like right in here, this can mess with your eyes a little bit, but actually running down through the grid and coming up underneath it. My coordinate out there would be that coordinate. Distance is, again, very similar to what you guys expect from like your regular geometry distance formula. So between 2 points where you have 2 coordinates, x and y, or between 2 points where you have 3 coordinates, x, y, and z, or points now, x, y, and z, it actually works identically. If I take this formula here and I cut off the third piece, this would be your distance formula from geometry. So essentially it's going to be a pretty straightforward idea. Take your distance formula and do your difference in your x's, difference in your y's, difference in your z's, add them all up, take the square root, 13.2. Now, if we were saying a vector from P to Q, and I found that 13.2, that would actually be called its magnitude. So distance formula here, actually translates to magnitude, and it would be the square root of a squared plus b squared plus c squared, which we'll do in a little bit with the same exact problem. But anyway, distance just like you'd expect. Pretty simple geometry approach there. We're also going to look at the equation of a sphere. Kind of ties up a little bit with conics, although we never did the equation of a circle, but the idea of the look of that formula, and even going back to geometry, actually, what it would look like. So, if you look at the geometry version and you have a shifted conic or a circle that's not centered at the origin, you have an HK center, move you away from the origin, like an ellipse, we'd have the same concept going on. And then a radius. So there's my shifted circle with my radius. Well, if you talk about a sphere in 3 dimensions, then you add in another value, you add a z in, and another value in the center. So now we have an h comma k comma l, still have a radius. The formula still works the same way. So again, this will seem very simple, I think, just like doing a circle. Given a center and a radius, plug into your equation. So x minus h, y minus k, z minus l, and then r squared. And r squared, this is 2 root 2 squared. And there's your equation of your sphere. So far, I think like the 9-3 stuff is really very easily relatable to geometry. That's why, of course, it's called 3D coordinate geometry. And the ideas are going to be fairly simple for you guys. And actually, even the 9-4 stuff, it's really when we get into the day after this where we start to ramp kind of back up into the little more complicated vector concepts. Then there is finding the equation of a sphere given given the general form of equation, finding its the sphere's equation like you'd expect. And we did this kind of problem with conics. We had a general form, and it didn't look like a conic, so it was your job to kind of translate this into. And the way you did that, if you guys remember, was by completing the square. So we had x and y, not a z component to it. But what we would do is we would regroup. We'd get our x's together, our y's together, in this case also our z's together, and then we start completing the square. And the idea is turn it from this form, which is a general form of an equation, into more specifically the kind of particular equation of a sphere. So the regrouping aspect of it would be, get your x's, y's, z's together. Then remember in our process, complete the square, half the middle term squared. So if you do half of all your middle terms squared, and then counterbalance that, and then clean it up. The cleanup part would be to get this written as x minus h squared. This is your y minus k squared, your z minus l squared, and then your r squared. And when you clean it up, there you go. Now, if I asked you to pull out the coordinate of the center and find the radius, the center is going to, of course, be an x comma y comma z. You remember this is r squared, so it'd be the square root of 24 or 2 root 6. So again, like the idea of coordinate geometry in 3D, actually everything works just like it did in 2D, even though we never called it 2D, and we're talking about conics, we're talking about geometry, but it all still works the same way. So that's really it for the 9.3 stuff. The 9.4 ideas, I'm going to shift to another video for that. So we'll have 2 videos. You can check the other one out here after you finish this, after you're done with this one.